Let's take a look at Grind 75, week 4, and problem number 1 is called 207 course schedule. All right. So I'm going to make this a little wider here so this thing doesn't wrap. Well, I guess I'm out of luck no matter what I do, right? Okay, that works. There are a total of num courses you have to take labeled from 0 to num courses minus 1. You're given an array of prerequisites where prerequisites of I is equal to A sub I, B sub I. Indicates that you must take course B sub I first if you want to take course A sub I. For example, the pair 0, 1 indicates to take course 0, you first have to take course 1. Return true if you can finish all the courses, otherwise return false. Huh. So this is essentially like building up a tree and then working your way through the tree to see if everything's connected. So the question is, can you take all the courses, and they're labeled from 0 to num minus 1. I guess what we could do is start at 0 and then look at all things that 0 has a prerequisite for, and then look at all those and look at all those. And if that covers the entire list, then you're done. Like this says, in order to take course 1, you have to take oh. So I'm just trying to understand the problem here. This is false. Okay, because in order to take course 1, you have to complete 0, but in order to complete 0, you have to take 1. So that's impossible to do. This is possible to do because you can take 0 and then you can take 1. Okay. Number of courses is going to be from 1 to 2,000. Prerequisites length. So the number of pairs is going to be from 0 to 5,000. And it's always a pair of, that's what this means. It's always a pair. And A and B are within the num courses range. All the pairs of prerequisites sub I are unique. I'm struggling about where to start, I guess. Well, let's meta start by modifying this thing. This is number 207, was it? Yeah, 207. All right, let's find out where that goes. All right. So here, if I say lib, okay, 0207 course schedule, right? Try to save it. It should fail. Create the module. And then what we're going to do is we copy paste this thing here, right? If I remember correctly, that's the way we do it. And then we can just return false and see, does that build? Oh, right, pub struct solution. I got to add that in order to get it to build. All right. So I guess now we have our two tests. Test mod, test 1. What is that? Oh, test like this. There, test 1. So we're expecting true. And this is solution, can finish. Num courses is 2, and the prerequisites are vec bang, 1, 0. And that test should fail. Especially if I don't write the code correctly. Yeah, okay, so it failed. All right. So what we can do is we can keep track of all the ones that we've completed, or we can complete. Or what we can do is make a list of all the courses that we have yet to complete. Or what we could do is, let's say if I create an array which contains all the courses, oops, this let's say vec bang 0 semicolon num courses, right? And then what I can do is for every course we have to complete in the prerequisites, I can add 1 to it. And then we can work our way through every course that has 0 in it, which means it's something that doesn't have a prerequisite, right? And then say that I can take the course that it's linked to. So in this instance here, the 0 doesn't have a prerequisite. So that means I can go to the 0th thing and see how many courses there are that you have to take before it, and then subtract 1 from that. And then if they all end up being zeros, then we should be done. So if I say for P in prerequisites, the course we're going to take, the course we need to take is P0. And the this is the course we're trying to take, and we need the prerequisite of P1. Right? Need. So now what we can do is we can say for that course, in order to complete that course, we have one more course we need to take. But we're going to need to map back. Okay, so after we do this, we should have, let's print this out and then see what this looks like, because this should give us an idea of complete of what we're looking at. So let's take a look here. We have to change this to usize, and this has to be usize as well. And this we don't need just yet. I think we're going to need it in order to map it, right? 0 and 1. Right, so this is saying course 0 has 0 prerequisites. Course 1 has 1 prerequisite. We can make another test that's a little more complicated. My test. We don't need that. So solution, right, can finish. Let's say there's 3 courses, vec, bang. Let's say course 2 requires 0 and course 1 requires 0, like that. And now, I forgot the bang. Right, so course 2 requires 1 course to finish it, and course 3 requires 1 course to finish it. We could also add another one in there and then say vec bang 2, 1. Oh. And now this says, let's do it the other way around, just so that it's not 0, 1, 2, because it's not as obvious, I think, what's going on, right? So this is saying that course 0 doesn't have any prerequisites. Course 1 has 2 prerequisites. It has 0 and it has 2 as prerequisites. And this has 1. So course 2 has 1 prerequisite, just 0. Right? And then we can look for all the entries that have 0 in the array and subtract all the courses that don't have any prerequisites, and then find out which ones they satisfy and subtract 1 from each one of those. Which means we do need to map this backwards. So let's grab the hash map. Use standard collections hash map. We can create a hash map. Let map is equal to hash map new. And then all we need to do is say map.entry of course, or insert. We're going to need to put multiple like I could make this a vec new, right? Dot push need. Right, and that way the map will have a list of all the courses we need, so we can actually print that out too. Map. So let's see if this gives us good info, good intel. So 2 requires 0, and 1 requires 0 and 2. That's true. And 1 requires 0. So now if we go through here, oh, do we want to do it the other way around? Or we could just, yeah, I think this will work. I might want to do this as a hash set instead, because that way we can just look it up. If I say hash set new, insert, like that. Right, so this gives us the same information. It's just that we can remove it without having to look up the index. What we can do now is we could say let courses that don't have prerequisites. What do we say? Completed courses? We already have the word complete here, or the variable name complete. Let let's just call it zeros for now. Maybe we'll come up with a better name. So we go through the complete array, iter, enumerate, and then filter out every entry that's 0. And then grab the first entry. And then collect. And that should be a vector view size, right? Yeah. So let's print that out as well. And that'll give us our starting point for all the work we need to do. Ooh, no implementation for this to this. Can I do that? Yeah, so both of these start at 0, right? So the 0 entry is our one and only thing. So now we can say, while let sum 0 equals pop, zeros pop. And then we can iterate over our map and find out if it has an entry in it for that. So like we'll iterate here, we'll grab this key value pair, and if this has a 0 in it, then we can subtract 1 from our entry. And this has a 0 in it, we can subtract 1 from the 1 entry, which is this guy. And then if we've hit a 0, if we subtract 1 all the way down to 0, then we can add it to our zeros list and keep going. For k value pair is equal to map.iter mute, because we want to change them. And we're going to say vremove. We're going to remove this guy here, right? 0. Then we're going to subtract 1 from our complete array. So, and that's the key. Right, the value is the map, and the key is the thing that we're subtracting from. So it's minus equals 1. And then if this ends up being 0, then we can zeros push k to work on it again. And these are unknown, unknown. Oh, beautiful. Why are these unknown? Oh, in. There. Oh, yeah. So now it's a hash set and it's use. Oh, it's an ampersand use size. So we have to do these things here. And then after each one, let's print out the new complete array. Print in after processing 0, we end up with a map. Oh, first of all, zeros with an E, and then second of all, it needs to be mutable. Oh, should it be an E or no? How do you spell zeros? Expected I32 found U size. Oh, should I do this? Yeah, as U size. All right, we're still panicking because we're still always returning false. In fact, there is one that should pass with a false, right? This is example 2, so let's do that one. This is EX1, and let's do a test here of EX2, and this should be false. So change this to bang solution, can finish. 2, vec bang, 1 0, vec bang 0 1. Yeah, so that test should pass. Yeah. So EX1 fails and my test fails. Okay, so the result now, after doing this, these are all empty, and I should also be able to print out the completion array / complete. And that should all drain down to 0. Yeah, so they're all zeros now. Once we subtract out the ones we don't care about, everything should be 0. So we could just do that, right? We could say complete iter sum equals 0. You probably need something else in there, like the type. Yeah, can't infer the type. Even though this is one of the frustrating things about Rust is we know that complete is a vec of I32. So we could assume I32 here for the sum, but for some reason Rust can't do that. Yeah, now all the tests pass. That's good news. Well, if I change this to a different type, let's say I size. Oh, it still works. Oh, U size. That might blow up, right? Because what if we have it sums to a negative value? It could just infer the I32, and then if you want to change it to something else, you could just force it to be that something else. All right, but I think we have a solution, right? Let's copy paste this in. Paste. Oops. There we go. I do need to include the hash map and hash set use statement. Right? And let's see if that works. I need to log. Oh, I didn't log in. All right, let me go over here so I don't. Reveal my password. There we go. And it very helpfully put my solution right back in there. Okay. So now I can submit. Ooh, output limit exceeded. Oh, yeah, because I got to get rid of the print line. Okay, let's get rid of all the print statements. Print limit. Okay. And now this, let's just copy paste this whole thing here. I am interested in seeing what they've got though. Wow, they got some big numbers here, right? Well, those are the course numbers. But if we look at the completion numbers, yeah, so there's a whole bunch of ones that take, I'm looking for double digits. I don't see any double digits in this particular test case. All right, so let's go here, paste, and now there's no output. Okay, that was accepted. That's good. How do we compare? Didn't it used to say how it compared? It's changed the stuff. It's changed the output since the last time we played around with this. Oh, okay, it's over here. Runtime is 120 milliseconds, which is all the way up here. So it's kind of slow. Some people ran it much faster, but I don't put too much stock in the runtime. The memory is going to be, yeah, and it beats 15.5%. Okay. Click to check the distribution chart. Where do I click? Here? Oh, I see. It just zooms it in a little bit. Click on the chart to check sample codes. All right, let's see the thing that takes 0 milliseconds. All right, this is very similar to what I've got, right? Finishable courses pop and it increments. Okay. This is very, very similar. All right, very good. We did course schedule. All done. Let's check that one off. Perfect. 1 of 8 done.